There's a couple things to consider that we'll go through before determining what the most efficient ways or increased value that could be applied to your next projects. First, we have to really understand the project scope and see if some of these existing technologies, whether it's archive data, LiDAR, aerial imagery through manned, unmanned aircraft, or through satellite technologies, are all viable options. So there's a couple of different survey, or there's various different survey purposes. Some of them include topographic surveys, plan and as-built mapping that might gain from photogrammetric efficiencies, right-of-way encroachment analysis that might gain from a multi-sensor platform, acquiring imagery, LiDAR, maybe even thermal, all in a single flight mission. Flood modeling, high-density LiDAR point clouds to produce accurate DEM models. Vegetation clearance detection, maybe more so on the utility end. 3D building creation, what kind of detail are we trying to achieve? Are we looking for just min and max height? Or are we trying to achieve roof pitch detail when creating these 3D buildings? And asset management is a big one as well that can also benefit from some photogrammetric efficiencies. Another key thing is to understand your project location and safety risks. We typically classify these different locations based on urban, rural, remote sites. And remote sensing technologies such as LiDAR, aerial imagery, satellite, UAV, they all offer an efficient and safe means of accessing or working in all three of these types of environments. With urban areas, we're restricted to high traffic environments, site access restrictions. Are there safety issues working on busy streets? What are the survey needs in working in some of these different environments? Rural areas, we're dealing with hazardous sites, steep embankments, difficult to walk through areas such as vegetation or heavily vegetated areas, forests, and then private land restrictions. And remote areas, well, we just all know that they're difficult and costly to get into. So trying to get an understanding on what these survey requirements may involve. On the topographic end, maybe there's a certain DEM accuracy you're trying to achieve. Are contours required? What's the contour interval that you're looking for? How large is the project? Are we talking about a couple hundred acres here, or are we talking about hundreds of thousands of square kilometers? Those are all three very key points in helping to understand what kind of technology you're going to apply to gain these efficiencies and improve that field safety. The feature collection, and maybe more pertaining towards the photogrammetry side of things, what are the features you're trying to collect? Are you trying to collect manholes? Are you trying to collect road edges or curb heights? Maybe a mobile mapping LiDAR system is better for collecting curb faces. Maybe large-scale photogrammetry is okay for collecting the edge of roads over large areas. Each one of those different cases are going to have a different horizontal accuracy that will be dependent for the survey needs. And then 3D modeling, what kind of detail is required? So a couple of technology considerations that's active in today's market. LiDAR is a hot topic right now. There's a lot of off-the-shelf LiDAR data sets, whether provincially owned or privately owned data sets as well. There are a lot of aerial LiDAR applications. Our company is flying manned and unmanned LiDAR systems to acquire accurate elevation over areas of various size. There's mobile LiDAR applications or technologies, and there's terrestrial as well. And then I'm more so on the photogrammetry side of things, that wonderful art of measuring from photography. We have, again, a lot of archive data available off the shelf, the Manitoba Provincial Air Photo Archives, privately owned data sets. There's a lot of options out there. And then also acquiring that through manned and UAV technologies along with satellite. Some existing privately held coverage in addition to what the province has. This was an area that was collected by our firm in 2016 and a little bit at the end of 2015. That entire data set was collected through a multi-platform system. So we're acquiring four-band stereo imagery at resolutions of 10 centimeter to 15 centimeter and LiDAR at point densities of 10 points per square meter to 5 points a square meter. So on the value consideration, depending on the technologies that we apply, we can, whether it be a UAV or an archive data set, it could be offer an elevation model for covering acres in as little as minutes. We could look at manned or satellite DEM options and archive as well that can require hundreds of square kilometers in hours. There's, again, taking a look at the project's requirements, timelines, and budgets. There's a lot of different options out there for improving your survey efficiencies. You can extend that survey potential too with the multi-sensor setups. So are you trying to acquire just an elevation model? Do you want to produce an orthophoto? Do you need to collect plan mapping or do some photogrammetric processes to it? Again, going back and understanding prior to all these considerations what your project requirements are will help understand and determine what the best sensor platform would be to collect that. For example, I mentioned that there's manned aircraft that are acquiring stereo imagery and LiDAR at the same time. It doesn't require two different flights. There's also UAV systems out there creating high-density point clouds and orthophotos at the same time as well. Depending on accuracy, depending on project requirements, it may or may not be a good option. So all of this will help to increase crew safety and field crew efficiencies. You're operating in. You don't have to spend as much time operating in these high traffic environments. You can reduce the survey time by eliminating the need for some site access or land access permissions. May not always be the case. You still need to get on site, but again, depending on the survey needs, you may be able to use something that's existing out there already, or a remote sensing method. So some examples on how some of our customers are using this type of technology. We had helped a customer out for 320 acres that required a field topo. The survey objective was to produce a 2-meter DEM with an accuracy of 9 centimeters or better. Some of his challenges were tight timelines, rural site location, and then driving a couple hours to get out there, a couple hours back. And there's only so many hours in the day to produce or for production. So we helped that customer out by providing them with a 1-meter DEM that was an archive data set and 4-band imagery. The product turnaround was within 24 hours, and he managed to save over $2,000 when compared to the other survey processes. We also recently had a customer who had to do about 5 miles of ditch profiles One of the issues or the objective was to collect elevation profiles along the top of the field, the bottom of the ditch, and the center line of the road. Well, his challenges were accessing the site or on the field side with private landowner restrictions, finding ways to get in there, or in some other cases they were limited with walking through heavily vegetated areas. So the quality of the data would be reduced through that ground survey method, but the LiDAR, we can't guarantee what the elevation profile is going to be at the bottom of the ditch. It's just a limitation of the technology. So in this particular case, the customer ended up using off-the-shelf LiDAR to grab the center line of the road elevations and the top of the field. And then he went in with his RTK GPS system on an ATV and basically just drove the bottom of the ditch. So he saved his survey time, or reduced 2/3 of his time in the field by eliminating 2 of the necessary collection requirements through the use of existing data. There's another one recently where there's about 16 square kilometers of 16 square kilometer area in southern Manitoba that required a drainage study. At that time, it was too large to go out and acquire data with a UAV. It was near winter conditions, and it's too big of an area to really go and survey through traditional ground methods. The solution was to provide data off the shelf, paired up with 4-band imagery, and collect infrastructure assets through a photogrammetric process. That entire data set was done in an as-survey condition, so the imagery and the LiDAR all being acquired at the same time. It was a data set that was conducive of the same vintage, and working with that ortho imagery in terms of classifying the point clouds have also helped improve classification, interpretation, and product turnaround. So we can take a look at some samples shortly here. In terms of maximizing value, if you could acquire more in less flights, then there's more possibilities in terms of the data sets that you can extract for those survey purposes. So here we just have a high-res point cloud. This is an area down in southeast Manitoba. This is a LiDAR data set that's representational of about 70 points a square meter. It's quite dense. The vertical accuracy that we ended up achieving on this was about 2.5 centimeters RMS. So it's a very high accuracy survey. Here's the same point cloud that's been feature classified. So we're the red, we have the buildings, the green is vegetation, and that orangish brown color is representing ground. So now looking between the two different models, here we can't really depict ground. We can see that there's some vegetation and some power lines, but if we're taking a look at the bare ground data, how do we know where that is? Well, using multiple returns per pulse, we could help filter out this information and then QC it with imagery that's surveyed at the same time. And when you acquire imagery at the same time, now we can colorize the point cloud. So here we have better interpretation of the road itself. So maybe if this project required point clouds to be classified to the road edge, and you wanted to know what the elevations are at the edge of that road, at the center line of the road, we would collect the vector information, classify that point cloud, and you could understand or start interpreting that point cloud specific to certain areas in almost a near world environment. And at the same time, we're collecting high resolution orthophotos. So this is just an area in Dauphin. That's a 5 centimeter photo taken. We're acquiring 5 centimeter imagery with our system at about 700 meters above ground. So, And that technology is also collecting 4-band imagery. So more so on advanced remote sensing platforms, if you want to get a better idea on standing water or soil saturations, there's also that extra added value as well. So in conclusion, existing data offers a quicker turnaround for topographic data. It reduces field time for planimetric feature collection. Multi-sensor platforms can reduce acquisition costs and reduce field time for planimetric feature collection as well. Key thing here is that it has to be equipped with a true metric camera, something that's calibrated, something that's a stereo frame sensor, and using a soft copy stereo workstation. That way you can state the confirmed accuracy. And all of this helps to work towards improving field safety as well. That's it for my presentation, and I'm going to leave the floor open to questions. Any questions?
So that area that you've mentioned with LiDAR in north and south of Winnipeg is huge.
Yeah.
And is that data being used or could be used for precision agriculture? Or what are some of the reasons RNs would want to use that?
Yeah, so one of the, from a strategizing standpoint, one of the reasons why we targeted that area was because the data that was currently available was out of date. It's over 12, 13 years old. The densities and accuracies are not the same or conducive to what today's technologies can produce. And we have had an influx of requirement or inquiries on the precision farming end. So precision farming groups might be using traditional ground methods to collect elevations of their fields. They might be using UAVs to collect these elevations. And we were able to position ourselves in a market where we can acquire this stuff at such a high efficiency. That whole area there we acquired in a month and a half with our system. So it's over 16,000 square kilometers. And all of that has cloud-free imagery as well, that 15 centimeter. Urban areas are done at 10 centimeter, such as the city of Winnipeg. So we were able to produce a product at a very large scale, drive the cost per square kilometer down, and make data readily available for people who maybe need updates just to their existing city data sets or provincial, municipal, or their own properties at a very affordable cost and a quick turnaround. So there's a lot of other value-added mapping too that we saw in that opportunity. One is asset management with Manitoba rural municipalities. They're all having a requirement now to implement and maintain an asset management plan. And asset management could be a very costly process to collecting that data that requires a lot of field time. So if we can provide a data set where we can collect even 1/3 of the required assets, we're still saving 33% of, or improving their productivity by 33%. So that was a big driving factor too in strategizing that. And we're just going to go ahead and start, collecting as much more data as we can. There's some areas up in northern Manitoba that we're targeting around Thompson, Gillam, and yeah.
Where do you see most LiDAR acquisition happen? In Canada or where's all your LiDAR collection?
Most of the LiDAR collection has occurred in southern Manitoba, central to the Red River Valley. Obviously, a lot of issues too on the flooding end there. So being able to provide a data set that's readily available to support emergency response is key. We've collected some stuff up in Ontario and Alberta. This coming year, we will be collecting a big block near the Estevan area of Saskatchewan, again targeting more so on the precision farming end There's a lot of potholes out there. It's difficult to survey by ground. It's very costly for people to survey. And there's a high demand for topographic data and a product that does not currently exist there.
So I've gotten a request for flooding potential or whatever in the Interlake,
Mm-hmm.
and you cover some of that.
Yep.
So are we able to tell patrons that they might contact you?
More than welcome. More than welcome. There's a question here. Do you have a question?
It seems your firm has really been in the forefront with this, with mapping approaches and data delivery.
Yeah.
Where do you see this going? I mean, the resolution keeps getting finer and finer and finer.
Yeah, we're,
What do you see on the horizon for maybe integration or?
well, multi-sensor platforms are going to be a big thing. We're under an evaluation of a new sensor right now that's capable of acquiring high-resolution LiDAR at 800,000 times a second, collect 4-band RGB imagery from nadir and 4 oblique angles, all from a single mission. So, you know, and we're looking at doing or implementing that as we build our LiDAR archive on a rural area. We also want to start building smart cities. And by building smart cities, we mean 3D modeling these cities, applying, you know, oblique texturing to them, getting accurate height elevation for cellular network planning, getting the monitoring elevations frequently to you know, detect erosion or help engineers on riverbank stabilization, and then track major construction projects as well. In the U.S., we're engaged right now on a project. We have a flight crew that just finished up in Arkansas, and now they're working in Texas before we head off to Kentucky. And in a month and a half, we have acquired over 20,000 square kilometers of LiDAR for the federal government. And that program is called the USGS 3DEP program. So it's a 3D elevation program. And the USGS at a federal level is funding a multi-billion-dollar project to collect high-resolution elevation data over all of the US. And certain areas have update frequencies a year apart from each other. Others are about 6 years. So as the demand for wide area elevation increases too, now sensor manufacturers like Harris Corporation are coming out with technology such as single photon LiDAR or Geiger mode LiDAR, which is capable of collecting, you know, 8 points a square meter at about 16,000 feet, which we would be collecting at about 5,000 feet with our systems. So they're talking about acquiring more land, higher density data over a bigger area in shorter time, but there's a lot of limitations with that as well. You got cloud and, you know, you got to hope for perfect weather days. So.